Example 12, working with a piecewise function. A cell phone company uses the function below to determine the cost C in dollars for G gigabytes of data transfer. So we have C of G, and we have it's going to equal 25 being a constant if the value of G is in between 0 and 2 and it doesn't include 0 and 2. And C of G is going to equal 25 plus 10 times G minus 2 if the value of G is greater than or equal to 2. So we want to find the cost of using 1.5 gigabytes of data, cost of using 4 gigabytes of data. So let's go ahead and start with finding the cost of using 1.5 gigabytes of data, and then we'll follow with the cost of using 4 gigabytes of data. Okay, so I'm going to go ahead and call this, we're going to just highlight this green, which is 1.5 gigabytes of data. So to find the cost of using 1.5 gigabytes of data, we need to put 1.5 and plug that in for the value of G to be our input. So we first look to see which part of the domain our input falls in. So if you take a look here, it says because 1.5 is less than 2, okay, we're going to use the first formula. So that means it falls within this domain. And since it falls within this domain, that means it's always going to equal a constant of 25. So therefore, C of 1.5 is going to equal $25. Now, in part 2, we want to be able to find the cost of using 4 gigabytes of data. So to find the cost of using 4 gigabytes of data, we want to find C with an input of 4. And we see that our input of 4 is greater than 2. So we're going to use the second formula. So here we can see that 4 follows that domain. And since it follows in that domain, then we got to use this formula here. So we plug in 4 and plug it into that formula. So we have 25 plus 10 times 4 minus 2. 4 minus 2 gives you 2. So 2 times 10 gives you 20. And 20 plus 25 gives you $45. So therefore, C of 4 is equal to $45. So this represents what we call a piecewise function. And again, it depends on which particular input falls within which domain and what formula you have to use. Now, the function is represented in figure 24, and we can see where the function changes from a constant to a shifted and stretched identity at G is equal to 2. And what I mean by that is, it's constant here at the number of 25 between 0 and 2. And then once we get to 2, we can see that anything is greater than is now going to start increasing as you move to the right.